Hi. We're going to continue our conversation about fitting an exponential equation to exponential data. I'll reemphasize again that this is not an exponential regression. That's a different procedure. It's different background mathematics. What we're doing is that we have a set of data here that we suspect is exponential, or we have some reasons to believe that it would grow according to an exponential model. And we're picking different points on the graph and finding an equation of an exponential function that goes through those points. We started with the points 0, 3, and 1, 5.5. And what we did was we took the point 0, 3, plugged it into the equation whose form was y equals ab to the x. And very quickly we found a. We subbed that in to y equals ab to the x along with the second point, and very quickly found b. So when we're done, we ended up with this equation you see here. So what do we know? Based on this equation, we can see by looking at the base that it looks like our growth rate is 0.833. So we're seeing about an 83% increase per unit along the x-axis. Every time we jump a unit of x, we go up an extra 83% in vertical height. Okay, so what I'm going to do now is I'm going to pick two different points. This time I'm going to pick the point 3, 27.5 and 4, 47.3 and redo the calculations. So 3, 25.7 and it was 4, 47.3. You'll notice that when we start off, if we take this first point and plug it into our equation, we get 25.7 equals ab to the third. We don't sort of luck out in this problem. In the previous example, we ended up with b to the 0, which was 1, and we got a right away. That didn't happen here. So this is going to take a little bit of extra algebra. We'll take this point and sub it in as well. And you probably can already see that we're not going to luck out here either. So here we are. We have these two equations. So what can you do? And actually, this would be something new to you, I would think. You can take these two equations and you can divide them. So 47.3 equals ab to the fourth, and divide that whole equation by 25.7 equals ab to the third. And when you do this, it actually turns out pretty nice. The a's will divide out to 0. On the right side, you get b. On the left side, we have to go do that in the calculator. So here we are, 47.3 divided by 25.7 equals 1.84. 1.84. Let's get an extra decimal so we shouldn't lose any. 0.5, I guess. Ask your teacher about what would be reasonable in terms of the number of decimals they want you to hold on to. So now we know b, and what we can do is we can pick one of our points. So maybe I'll pick the first point, 3, 25.7, along with the b value. So 25, oops, hold on a second. 25.7 equals a, which I don't know, times b, which now I do know, 1.8405, to the third power. And this is another equation we can solve quickly. We'll take 25.7 divided by 1.805 to the third. So here we go. 25.7 divided by 1.8405 to the third. Luckily, your TI-84 knows order of operations. It will do the third power of the denominator first and then divide. And we get an answer of 4.1222. So there's A. A is approximately 4.1222, which implies our equation now is y equals 4.1222 times 1.8405 to the x. So that's a second equation that might model this data. What we could do now is plug this in to our T84 and see how well it does in estimating the other points. You can do this several more times. We have other points we could use. So for example, if we go back to our original picture, maybe we want to use the 1, 1 point, or the 1, 5.5, and the 4, 47.3. The procedure is the same. I'm just going to start that problem. I'll let you finish it on your own, but there's one interesting thing that happens when you start that problem. So let's get a new page. If you use the point 1, comma 5.5 and 3, comma 25.7, for example, then you'll sub in. You'll get 5.5 equals AB to the 1, and 25.7 equals AB to the third. You don't luck out again. Again, you didn't have this situation like we did the first video where b to the 0 would cancel right away for you. So we're going to divide these. 5.5 equals AB to the first. And what happens this time is when you divide them, the a's cancel again. But on the right, you get b squared instead of just b. On the left, you get 25.7 divided by 5.5, and it gives us 4.67272. So 4.6727. And to get b now, you need to take the square root of this b squared. So that's the extra step that's happening in this problem that didn't happen in the other one. You just had b equals. So we'll do the square root. Let's do second square root of our answer. You can enter, and you get about 2.161. Okay, so that's your value for b. You would take that, plug it into the equation along with one of the 2 points above that you have here, and solve for the corresponding value of a. So you'd end up with different, 3 different equations to model the data that you have, and then you come up with some reasonable argument as to why you pick one over the other. This one has a very high b value. Maybe you think the 2 points you picked just yielded one, and on average, the b value should be maybe 1.9 or something like that. You'll have to make those decisions. This kind of algebra will be important when you start to analyze the health insurance problem. Okay, thanks for watching.